Hey guys, so we are getting ready to go over your quiz / get ready for your test, last test of the semester, which is great. So we have to figure out if this is arithmetic, geometric, or quadratic. So remember, geometric is the only one that we have to multiply. Arithmetic, we go one line or get repeats. Quadratic, a lot of people keep thinking quad meaning 4, but it really is 2. Remember, your x squares are quadratics, and cubic is 3. So what we're going to do here is 20 minus 8. Oh, Lord. What's the daisies? I was having 8 on my mind. 20 minus 8. When we subtract there, we get 12. 40 minus 20. 68 minus 40. And keep going. We're going to keep subtracting. And notice here, we do not have any of the same. By the way, geometric, can I multiply anything by 8 to get 20? No. So now we're going to go the next line. 20 minus 12 is 8. 8, 8, and 8. So this thing here is quadratic. Let's see. Okay, now the next question is going to be, what is the next sequence of numbers? So this is where you're going to add up all of these numbers. Whoops, that's an addition sign. So when you do that, you get 200. So the next term is 200. Okay. Let's see, let's move that back up. Find the sum, okay, the geometric term. So the formula for a sub n, okay, there's only two formulas we have here. R to the n minus 1, and then the sum one. So a1, r to the n minus 1 over r minus 1. I know Mr. Ford has it, these flipped. These are really the same way. It's just I've taught so long for this formula, it's the same. Just notice if r is first here, it has to be first at the bottom or the 1. Okay, these are really the same equations. But let's go back to this one. This is the one we started off with. So remember, here is a1. Now, if I don't have a number in the front, it is an understood 1. R is the one that's always attached with the exponent. Okay, let me just, that's what I'm pulling here. Because this starts here with 1, here is my n. Okay, so sum is 2 times 4 to the 10th minus 1 over 4 minus 1. Please be careful if you put this whole thing in. You can do one of two things. Let me just move this down. Put this in parentheses, or I just go ahead and put this in as 3. So when you type all this in, and I don't want to confuse anybody there, you type this in, it is geometric. You're going to get a very big number. Okay, that will happen in geometric, not so much with arithmetic. Okay, so remember, by knowing the original equation, we can actually come up with all this stuff here. Okay, we need to come up with the 75th term, and this is arithmetic. Okay, so let me go flip here. Let's see, flip here. So you see Mr. Ford, where is it? To find D. Subtract the second term by the later term by the earlier term. In Ms. Vetrano's term, second first. Okay, and then divide by the number of jumps. Okay, so here we go. We've got to find our D value. 2989 minus 1189 all over 31 minus 13. And if I remember correctly, this is 1800 divided by 18. So my D, I'm going to rewrite it here. D is 100. I'm trying to find a calculator because I'll know I'll need it later. So now then we have choices. We have to find the formula see, so this is AN equals A1 plus D times N minus 1. So before I can find the 75th term, I need my first term. So we do have choices. You choose the one you think is the prettiest. And I'm going to go with this one. So that means this right here is my AN, and then this here is my N. So we're going to plug in. So 1189 equals A1 plus, remember D was 100, times 13 minus 1. Okay. Now I'm going to put this whole thing in. So 1189 equals A1 plus, and I'm going to get 1200. Subtract 1200, I believe, and I believe it's negative 21, but I don't know how Miss Vetrano can be sometimes. Where's my calculator? Don't you hate it when you can't find your calculator and people are waiting for you? Minus, whoops, go back, delete, whoops, here. Negative, I am so sorry, negative 11. I did say 21, didn't I? I know someone was probably yelling at me on the phone or over the internet. Okay, remember D, it was 100. Going back to the original problem, we want the 75th term. So this becomes my N value. Whoops, a daisies. So here we go, A to the 75th term. So negative 11 plus 100 times 75 minus 1. And I would type this whole thing in, and you should get 7389. Okay. So some of these you have to do a little extra to get there. I'm going to be honest, love this first 4 terms. So what you're going to do here is plug in 1. Let's see, N equals 1. So you're going to just do negative 12 times 1 plus 22. We get 10. And then you're going to plug 2 in. Negative 2. 3. So negative 12 times 3 plus 22. You're going to get negative 14. Then plug in equals 4. And then you're going to get negative 26. So cute little plug and chug. Okay, arithmetic. So this tells us the formula is N divided by 2 times the first term plus the last term. Those are equal signs. Okay. We want to be careful here. My first term is actually not 1, it is 3. So to find my first term, which really is my third term, you're going to plug 3 in. So 6 times 3 minus 14, which is 18 minus 14, which is 4. My AN term, which is right here, which is that last number on the top, is 16. So now I'm going to plug that 16 into the equation. So 6 times 16 minus 14. And if I remember rightly, I believe it is 82. Okay. Now we got to figure out N. And this is where we have to be careful. 16 is not our N because we're not starting here at 1. This became a question in the class. We don't want to do 16 minus 3 because that is going to definitely give us 13. And the answer is not 13. So we're going to count. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I forgot my 1, and then 16. And if you count all of these, you're going to find out that N is 14. Okay, so here we go. So to find the sum, it's just going to be 14 over 2 times 4 plus 82. I am so sorry. 14 over 2 times 4 plus 82. I was mathing in my head, which can be dangerous. And you're going to get 602. Remember, it is arithmetic, so that is a good number to have, not too big. Okay. We have a geometric sequence. So here, let me go back. Let me click on here. To find R, divide the later term by the earlier term. So later term is 2, the second one, earlier term is the first one. Okay, so step 1, 32 divided by -4 is -8. Okay, then take the root of the quotient by the number of jumps. How many jumps do I go to? So 5 minus 2 is 3. Now, 2, 3, 4, 5. Jumps mean here. So 1, that's 1 jump. 2, 3. So it's a little different from what we were doing in the last problem. We had to count that first term. So take the root. So cube root of -8 is -2. Okay, this becomes my n. Okay, and then we have to figure out the first term. So I've had several people just go backwards. You can do that. I'm going to use this guy. So here's my n, here's my an. So -4 equals a1. By the way, using this equation. This is the only equation we have for geometric because we're not asked to find the sum. Okay, so 2 minus 1. So type this all in. You get -4 equals a1. And then this comes out to be -2. Divide by -2. So a1 is 2. Okay. So here we go. So the 15th term, a to the 15 equals 2 times -2 to the 15 minus 1. And you're going to type all that in, and you're going to get 32,768. Okay. I hope this is making sense. Okay, John bought a car for $90,000. So that's my A1, 90,000. According to Kelly Blue Book, the depreciation rate of the car is 16%. So now, remember when we're dealing with percents, by the way, this would be a geometric because of the percentages. 100% of my car would be 90,000. It's depreciating, so we're going to subtract 16%. And we're going to get 84%, but we need it as a decimal, so 0.84. So now the question is, when is this car going to be worth $5,000? So essentially, we're setting this up. 1, 2, 3 equals 9, 1, 2, 3, 4 times 0.84 to the n minus 1. This is a very difficult problem to solve. So what we're going to do is something called guess and check. Okay, so when do you think a $90,000 car will get to 5,000? So what you could do is start guessing. So for instance, let's hope a $90,000 car does not go down that low that quick. So I'm going to type in, and this is what I'm typing into my calculator, 2, 3, 4, 0.84 to the 10 minus 1. Okay. So 1, 2, 3, 4, parentheses, 0.84. And I'm just going to type in to the 9th because 10 minus 1 is to the 9th. And I still get $18,739. So that's still a lot. So we can go, let's see, A15. I'm not going to write it out again. So second enter. So that becomes, let's see, delete 14. We're at 78.37. Okay. I'm just going to go up by 2 years. So second enter. So 17, and so that'll be to the 16th power. Ooh, there we go. I'm hitting pay dirt, $5,529. So let's go to the 18th. And I get 46.45. So would you agree somewhere between the 17th and 18th year, it'll get to be less than 5,000? So we're just going to put it in as a range of numbers. Okay. I'm just going to see how am I doing on time. Okay. What I'm going to do, let's just keep going. We'll just keep going. Okay. Do y'all see the R right here? So R automatically makes this a geometric, okay, and rounded to decimal places. So R this time is going to be a decimal value. Okay, so after 5 months, it's 6,782, and after 10 months, it is 2514. So going back to what Mr. Ford said here, later term by the earlier term. So this is my second, so 2514 divided by 6782. 6782, we get 0.37. Oops. So now what we're going to do is how many jumps? So 10 minus 5 is 5. So what we're going to do here is take the fifth root of 0.37. Okay, and when you do that, you're going to get 0.82. So there is your final answer on here. You are supposed to get a decimal, right? And it makes sense because we are decreasing in there. Okay. So looking here without even reading, this is arithmetic. Okay. Colin Red Mills has become a top seller of horse feed for the customers to order 50 bags. So A of 50 is 2,515 for 100 bags. So A of 100 is 5,015. Okay, so to find D, second term, and again, if you forget, it's right there on the separate paper on the first page. In that first box, subtract the later term by the earlier term, and then divide by the jumps. So 50,000 or 5,015 divided by 2515 over 100 minus 50. That's going to be 50, and this should be 2,500. So A is 50. Okay. Now we got to figure out the first term. We do have two choices. You pick the one that is the cuter. What I'll just do, I'll show you. This time I'll choose the second one. So the formula we're given, the only formula we have is this one, A1 plus D times N minus 1. So AN, so AN and N. So 5,015 equals A1 plus, there's my D, 50 times 100 minus 1. And so what we're going to do is put that in there. Please clear. Whoops. Nope. Okay, 50 times 99. Okay, so 5015 equals A1 plus 4,950. Okay. If you would have chosen the first one, this is where we're going to be a little different, but we're going to still get the same answer. Now we're going to subtract right here, and we get 65. Okay, so there's that. So we want the explicit formula. So AN equals 65 plus 50 times N minus 1. So please remember, do not leave it like that. We want it all cleaned up. So distribute your 50. So you're going to get 65 plus 50 N minus 50. Okay, let me just move myself down a little bit more. We're on the same side, so this and this. our like terms. So 60 minus 50 is 15 plus 50n. So an equals 15 plus 50n. Okay. Or you could do 50n plus 15. Again, it doesn't matter as long as everybody is positive in this situation. Okay. Central High just opened up with 2,000 people. So we know A1 is 2,000 people. According to the district, estimated population growth is 7%. So this is geometric. Okay. The formula is AN equals A1 R to the N minus 1. Okay. So to calculate R, so let's always start off with 100%. And we're growing, so we're going to add 7%, sorry. We're going to get 107%. We do need this as a decimal, so it's 1.07. Okay. So this is just like the car problem we had. So AN equals 2,000 times 1.07 to the N minus 1. Okay. The building has a max capacity of 5,000 students. How many years will this take? Okay. Sorry, let me get there. So the question here is 5,000 equals 2,000 times 1.07 to the N minus 1. So we're going to start playing around with the numbers. Okay, so I know some of my students in the past said 5. So again, I'm going to type in this. So 2,000 times 1.07 to the 5 minus 1. Okay, 2, 3 times 1.07 raised to the, nope, I messed up. 1, 2, 3 times 1.07 raised to the 4th. And we get 2621. So that is way too small. We're trying to get 5,000. So let's go. I'm going to add 10 years to this. Oh, sure. There. 1, 2, 3, 1.07 raised to the 14th. Okay, so 5,157. So it looks like I'm a little over. So let's make sure the 14 will work. So let's go up there, delete, and we get 4819. So we would hit 5,000 anywhere between the 14th and the 15th year. Okay. Let me scroll up. Arithmetic. So our formula is AN equals A1 plus D times N minus 1. Okay, they gave us D. So we got to figure out A1. So A1 is here and N is here. I'm sorry, AN. So sorry. 3,323 equals A1 plus 175 times 17 minus 1. Okay, let's just go right here. Let's clean that up. Minus 1 parentheses. Okay, so 3,323 equals A1 plus 175 times 16, 2,800. Okay, sorry about this. I'm not synced up, as you can tell. Now subtract 2,800. And you're going to get 523. That's our first term. Okay. So now we're going to find our explicit term. So AN, our equation, so sorry, 523 plus 175 was our D, N minus 1. Remember, we do need to clean this up. So distribute. So 523 plus 175n minus 175. Because these are on the same sides, let's collect like terms. So 523 minus 175 is 348 plus 175n. Okay. Geometric. So 1, 2, 3, 4, 5, 6. I need to find R. So 1458 divided by 54 is 27. How many jumps? 1, 2, 3. So cube root of 27 is 3. So all we're going to do here is multiply by 3. So 54 times 3 is 162, times 3 is 486, times 3, make sure it gets us there, to 1458. So if I multiply to get bigger, I'm going to start dividing. So 54 divided by 3, and that gets me 18. 18 divided by 3 gets me 6. Okay. Arithmetic. So 1, 2, 3, 4, 5, 6. Okay, let's find D. 422 minus 34 all over 6 minus 2. So 422 minus 34, sorry about this. 422 minus 34 is 388. Divide by 4. I got D is 97. So we're going to start here. Add 97. So 34 plus 97, make sure I'm right. So I got 131 plus 97, 288 plus 97, 325, and this is where I hold my breath, plus 97, and it does get me 422. So what we're going to do is 34 minus 97, and that does give us 63. Okay. And last question. Infinite. So this means this is the, oh, sorry, messed up. Okay, let's take 2. Here's the only equation we have. And just remember, R is less than 1. Okay, so again, remember this formula. So we can pick everything we need out right away. R is always with the exponent. So here's my R. It is less than 1. Okay, and here's my A1. So S equals negative 12 divided by 1 minus 1/2. I always like to put it as a fraction. Okay, so negative 12, 1 minus 1/2 is 0.5. So the final answer is negative 24. I hope this has helped. If you have questions, feel free to see me or Mr. Ford, or if you look on your test.